Okay, in this video we're going to be talking about degree of unsaturation. So what does it even mean to have a saturated molecule? Well, think of saturated fats. They're straight like this, they don't have kinks, they are straight. And the saturated fats are just comprised of CH bonds. It's a CH chain, right? So there's hydrogens just saturating all these carbons. So that's what it means to be saturated as a molecule, to be fully covered by hydrogens as much as possible. Now, unsaturation would entail a double bond, a pi bond. And by introducing this pi bond, we have to get rid of this hydrogen, CH bond, and this CH bond to sustain the octet rule for carbon. And when we introduce this pi bond, well then this can kink, like so. And so this one saturated fat is now considered unsaturated because these carbons are not being saturated to their full extent by hydrogen atoms. There's a pi bond here. Okay, so if you take any molecule, we'll work with propane, and we multiply the number of carbons by 2. So we have 3 carbons, 1, 2, 3. Multiply this by 2 and add it by 2. We get 8. 8 is the maximum number of hydrogens we can have in a saturated molecule. As you can see here, we have 8 hydrogens. And so for degrees of unsaturation, it is denoted by lowercase d. What this equals to is 2 times n, which is the number of carbons, plus 2, put this in parentheses, minus number of hydrogens plus halogens, divided by 2. Now, if we get a degree of unsaturation of 1, this indicates a single pi bond, a double bond, right? Or a ring in the molecule. Okay, so let's go through this now. Okay, so let's say we have this propane. 2 times how many carbons are there? 1, 2, 3. 3 plus 2 is 8. How many hydrogens do we have? We have 8 hydrogens. 8 minus 8 is 0. 0 divided by 2 is 0. So D equals 0. The degrees of unsaturation is 0 because propane is fully saturated with hydrogen atoms. Now let's say we have propene. Let's delete all this. We have propene. Well, we still have 3 carbons, right? So 2 times 3 plus 2. Okay, that's 8 still, right? Well, how many hydrogens do we have? Well, we have 3 here. We have 1 here now. We have 2 here, so that's 6. There are no halogens. So it's 8 minus 6, which is 2, divided by 2. 2 over 2 is equal to 1. So degrees of unsaturation is equal to 1. And like I said before, this is an indicator for a single pi bond or a ring. And in this case, it is that single pi bond that we see right here. So it's quite clever. So let's do an example. What is this? This is going to be cyclopentane, right? Because we have 5 carbons. So 2 times 5 carbons plus 2 is going to give you 12, minus how many hydrogens? Well, we have 2 here, we have 2 here, 2, 2, 2, and 2. So we have 10, right? 2, 4, 6, 8, 10. So 12 minus 10 is 2, divided by 2 is 1. So degrees of unsaturation is 1. That's an indicator for a pi bond, which is not there. We don't have any pi bonds. It's still an alkane, but there is the presence of a ring. So yes, this is quite clever. Now, if we have degrees of unsaturation of 2, let's say, if this was, actually, let's just, do an example here. We have this one. So 1, 2, 3, 4, 4 carbons, 2 times 4 plus 2 is 10, minus how many hydrogens? Well, we have 1, 2, 1, 1, 1, 2. This is 6, yep. So divided by 2, 4 divided by 2 is D, which is equal to 2. So we have degrees of unsaturation of 2. So degrees of unsaturation of 2 indicates the presence of 2 pi bonds. Okay? And it's 2, right? Because it's more unsaturated. We have less hydrogens with the introduction of all these pi bonds, with the introduction of all of these double bonds, right? And that's it